Hello viewers, in today's session we are going to discuss an important conceptual problem from domain of functions, and in this session we are going to find out the domain of this function f of x, that is equal to a square root of tan inverse, and here we have the natural log of x, right? So in order to find out the domain of this function f of x, that is the valid values of x for which this function is defined, we have to make use of some concept from inverse trigonometric functions, right? So from inverse trigonometric functions, we know that tan inverse theta, the range of tan inverse theta, it belongs to this interval, that is the open interval minus pi by 2 to pi by 2, where this theta, it belongs to the set of real numbers, right? So this is the concept behind finding out the domain of this function f of x, because here we have tan inverse natural log of x, so we can take theta is equal to natural log of x, right? So now from this statement we can say that here we have minus pi by 2 and here we have pi by 2, and between minus pi by 2 and pi by 2 we have 0. So our tan inverse theta, the range of tan inverse theta is from minus pi by 2 to pi by 2, and remember here these two endpoints are not included, right? So now let us come to our function. So here we have the square root function, right? So the first condition is that this quantity, that is tan inverse of natural log of x, should be greater than or equal to 0, because this quantity has to be positive under this square root sign, right? Because if this quantity is negative, then we have a negative quantity inside the square root sign, and these quantities belongs to the set of complex numbers, but here we are dealing with only the real numbers, right? So tan inverse natural log of x should be greater than or equal to 0. So now if we take natural log of x as theta, then this inequality now reads as tan inverse theta is greater than or equal to 0, right? So now let us come to this diagram or the real number line. So tan inverse theta is greater than or equal to 0. So here from minus pi by 2 to 0, we have the negative quantities, right? And here from 0 to pi by 2, all the numbers are positive. So now tan inverse theta has to be greater than or equal to 0. So we have to now consider only this interval, right? That is from 0 to pi by 2, because tan inverse theta is to be positive. So we cannot take this interval, that is minus pi by 2 to 0, because tan inverse theta has this range minus pi by 2 to pi by 2. So we have to discard all these numbers or this interval from the range of tan inverse theta. So now we should write here tan inverse theta is greater than or equal to 0, but it should be less than pi by 2, because here the value of tan inverse theta cannot be equal to pi by 2, or it cannot go beyond pi by 2, right? So now we have this inequality, that is tan inverse theta greater than or equal to 0 but less than pi by 2. So we have to restrict ourselves to only this interval where 0 is included, but pi by 2 is excluded, right? So now we can write here for theta, and that is the natural log of x. So we have 0 and tan inverse natural log of x, and here we have pi by 2. Now taking the tan function of these three quantities, we have now a tan of 0, and here we have tan of tan inverse natural log of x, and then we have here a tan of pi by 2. So what we have done here, we have taken the tan function of all these three quantities. So now the value of tan 0 is 0, and here tan inverse natural log of x is simply natural log of x, and here tan pi by 2 is not defined, that is we can write here infinity. So here we have used this result, that is tan of tan inverse alpha is equal to alpha from the properties of inverse trigonometric functions. So now the next step is to get rid of this natural log, right? And here we want to have only the quantity x. So what we will do, we'll raise these three quantities to the power of e, where e is the exponential number. So we have e raised to 0, here we have e raised to natural log of x, and here we have e raised to infinity. Now here we have e raised to natural log of x is simply x, because this is a very famous result. So e raised to natural log of x is equal to x, and e raised to 0 is 1. So we have 1, and here we have simply x, and e raised to infinity is infinity, because we know that e raised to x tends to infinity when x tends to infinity, right? So now we have x greater than or equal to 1 but less than infinity. So the domain of this function f of x is given by x belonging to this interval, that is closed from the left, that is 1, and here we have infinity. So this is the required domain of this function f of x, and here we have the real number line. So this is minus infinity, this is plus infinity, and here we have 1. So this is our domain, including this point, that is x is equal to 1, and it can also be verified by substituting x is equal to 1 in the function. So the function is very much defined for x is equal to 1, because when we take x is equal to 1, then a natural log of x, that is natural log of 1, is 0. So we have f of 1 is square root of tan inverse of 0, and tan inverse 0 is 0, so we have 0. So this is the domain of this function f of x.